Scientific notation. The basic form of scientific notation is a times 10 to the n. Large numbers are bigger than 1. They have positive exponents. Numbers between 0 and 1 have a negative exponent. So for instance, if I have the number 6,320,000, the decimal needs to move between the first two digits in order to be in scientific notation. The original number here is larger than 1, so I have a positive exponent. So basically, my decimal point is at the end. If I move it 1, 2, 3, 4, 5, 6, it has to move 6 places to get between these first two digits. So that's 6 moves. The value of the exponent is equal to the number of moves. And I've already determined that it's a positive exponent because my original number is greater than 1. So it's going to be 6.32 times 10 to the positive 6. If I have the number 543.26, here again my number is bigger than 1. I will have a positive exponent. I have to move it 2 moves to get it between the 5 and the 4. So the 2 moves is my 10 to the second. So it's going to be 5.4326 times 10 to the second. Here, this number, 0.00593, this number is between 0 and 1, so it's a negative exponent. I still have to move it 1, 2, 3 moves to get it between the first two digits. So it's 5.93 times 10 to the minus 3. The moves was 3, but it's a negative exponent because the original number was between 0 and 1. Now if I'm going from scientific, expressing it as standard notation, if you're given the number 2.32 times 10 to the 4th, here you first look at the exponent. It's a 4 and it's positive. So that means my original number was bigger than 1. So in order for me to move this decimal, I have to move it this way to the right because that will make my number bigger. So 1, 2, 3, 4 moves. I add some zeros if I don't have enough spaces. So it's basically 23,200. I had put an extra 0 here, so I don't need that one. If I have 1.63 times 10 to the minus 5, here I have a negative 5 exponent, so my original number is between 0 and 1, so I have to move the decimal in the correct spot. So if I move it left, I have to add some zeros, but I have to move it 5 places, so this is 1, 2, 3, 4, 5. It goes right there now. So 0.0000163. When you're multiplying, you multiply the a's, add the n's. So 4.6 times 10 to the third multiplied by 7.2 times 10 to the fifth is going to be 4.6 times 7.2. Add your exponents, 10 to the 3 plus 5. So you get 33.12 times 10 to the 8. Here you have to make an adjustment because 33, it has to be, the decimal has to be between the first two digits. Or another way to think about it is A must be between 1 and 9. And it's a 33. So 1 and 9 are single digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all single digits. As soon as I get beyond 9, I'm into double digits. So here, I have to move it one place, which is making it smaller. So the original number is 33, but now I'm making it so it's going to be a 3. So this is one move smaller, so I have to add 1. So it's the opposite move. If I move smaller, that means I have to add to the exponent. If I move larger, it means I have to subtract from the exponent. So 1 smaller here, add 1 to the 8, so you get 3.312 times 10 to the 9th. When you're dividing, here you divide the a's and subtract the n's, and of course make adjustments if you need to. So 4.2 times 10 to the 5th divided by 2.1 times 10 to the 4th, that's going to be 4.2 divided by 2.1. Subtract your exponents, 5 minus 4, so it's going to be 2.0 times 10 to the 1st. No adjustment is needed here because the 2 is fine, the decimal's in the right spot. But if I did this problem down here, 7.63 times 10 to the minus 10 divided by 9.2 times 10 to the minus 5, when I divide my 7.63 by 9.2, subtract my exponents, so minus 10 minus a minus 5 becomes minus 10 plus 5 on my exponents. But doing the division, I get 0.8293 times 10 to the minus 10 plus 5. or 0.8293 times 10 to the minus 5. I need to make an adjustment because this number here, I need one digit out in the front here and I don't have it, so I've got to move the decimal. So I move it one larger, I have to subtract one here. You still have to remember the rules of adding and subtracting, so it's minus 5 minus 1, which makes it a minus 6. So moving the decimal gives me 8.293 times 10 to the minus 6. Engineering notation uses powers of 3 for the exponents. So 4.6 times 10 to the third, this is in scientific notation because you got one digit here, but it's also engineering notation because of this 3. It's a multiple of 3. And a 3 in terms of metric prefixes is a k. So you could also write this as 4.6k. So pretty much you can take this times 10 to the 3 part and convert it over so that it's a k in the metric prefix. And you don't need to write the whole thing and just put a k. 5.29 times 10 to the 6. The 6 is a meg, capital M. So you could write this as 5.29 capital M for meg. If I have 45.29 times 10 to the 4th, this is neither scientific or engineering. It's not scientific because I have double digits here. And it's not engineering because this is a 4. It has to be a multiple of a 3. So if I want this to be in scientific, the decimal needs to be between the first two digits. So that's one move smaller to get it over here. So when I move that smaller, I add 1 to the exponent. So it becomes 4.529 times 10 to the 5th. That's the scientific part. If I want to do engineering, I need a multiple of 3 on the exponent. So I could go from a 4 to a 6, which is adding 2. So if I'm adding 2 to the decimals from 4 to 6, I need to make this smaller. Remember, opposite move. This gets bigger, this gets smaller. So bigger by 2, smaller by 2. So that moves over twice. So it's 0.4529 times 10 to the 6, or you could write it as 0.4529 meg. This is not scientific, because again, scientific you'd have to be right here between the 4 and the 5. But it is engineering because this is a multiple of 3 and you can replace it with a metric prefix. But I could also go, I don't have to go 4 to 6, I could go 4 to 3, because 3 is also engineering. So if I'm going from 4 to 3, this is getting smaller by 1. So I want to make this bigger by 1. So I would have 452.9 times 10 to the third. And again, 10 to the third, I can replace that with a k.